so it gives me a great pleasure to welcome our guest, Greg. So, awesome. We are actually quite lucky we have him here because starting from December, we start a lot of trips, right?
It's January, no more travel.
No more travel, yeah, exactly. So yeah, I don't have a lot to say right now. So basically, please welcome our guest and let's start this presentation. Thank you.
For those that don't know me, my name is Greg. I've done a lot of stuff with CQRS and event sourcing over the last 8 years. We'll talk about that a bit more. What we're going to be talking about today is polyglot data. How many have heard of polyglot data? Not very many. How many have heard about event sourcing? Okay, quite a few. So I'm going to be stuck in the position of trying to explain event sourcing to people that don't already know it, while not boring all the people that do already know it. That's a really hard position to be in. So you may get bored for about 10 or 15 minutes, but don't worry, there's more stuff that we're going to go over afterwards. We've only arrived about an hour ago here in Wrocław, but we're looking forward to the next couple days, and if people know really cool places to go, let me or my wife know, and hopefully we can get to them. We were lucky enough to take a flight as opposed to a Polish train on the way here. Otherwise, we'd be here like next Tuesday. So let's just jump right into it. And it helps if I turn on the clicker. Just so that you know, if you have questions, feel free to ask them as we're going on. If you don't feel comfortable speaking up, like when I'm talking, if you raise your hand, I'll probably see you. If I don't, it's your fault. No, I'm kidding. But raise your hand if you don't feel like just interrupting. Really, you will not bother me. I'm an American, and we are known for our subtlety in conversation. You will not offend me with a question. Now, what we're going to start talking off about is event sourcing. I've been talking about event sourcing for a lot of years now. And what's always struck me as odd is when we first started doing event sourcing, it actually came from algorithmic trading systems and core back-end gambling systems that would handle things like your lottery. That's weird. Why would I be talking to people building business systems about it? But what we started finding was, after working in these kinds of systems, we started going off and we were actually working as consultants on a bunch of regular business systems. And when we started applying event sourcing the same way we built these other systems, we found a whole bunch of other benefits. And this is what people are normally more interested in about today. It's the other benefits, aside from the fact that you could do, let's say, 50,000 transactions per second. How many of you do 1,000 transactions per second today? Okay, a couple. And event sourcing is very, very useful in the kinds of systems that are doing thousands of transactions per second. But it's also useful in a lot of other business systems for a whole lot of other different reasons. Now, as I mentioned, we're going to be learning integrals today. No, I'm kidding. So, what's interesting for me is if I go back and look at mature industries, and by mature I do not mean things like Groupon, I mean things like banking, finance, insurance, bookkeeping. Not a single one of them has a concept of current state. That's weird, right? Think about what you were taught in university. Your current state is the most important thing of your entire system, and you should begin by figuring out the shapes of your data in the database. But yet in mature industries, from a business perspective, they have no concept of current state. How many of you have a bank account? Do you think your balance is a column in a table? Or is your balance an equation of the summation of the value of your transactions? And don't worry, that's the last math I'm going to write on the board. We won't be doing many more integrals. I feel really bad for whoever was sitting here when they were writing that. But what if your balance was just a column in a table? How many of you had a disagreement with your bank over your balance? What would happen if I called them up on the phone and it was just a column and a table? And I would say, I think I should have 10,000 zloty. And they say, no, you should have 1,023. All hail the column. The column says 1,023, you should have 1,023. But what happens if it's actually an equation? Can we go through and manually compute this equation and figure out if the computer added them up correctly or incorrectly? Now, I may put your balance inside of a column, but that's a denormalization. That's just there so I can query it quickly. At any given point in time, I can tell the computer system in a bank to recalculate every balance inside the bank. And the same thing happens when we start talking about accounting. Accounting, almost everything you need to learn about event sourcing can be found inside of accounting. But there's lots of reasons why all of these mature industries have given up on the concept of current state. Current state sucks. It's almost useless from a business perspective. We're going to go through and look at lots of examples of this. But the main reason why is because if whatever form of current state you decide to choose, it's going to lose information. How do you determine what information you can lose or not lose? You end up in these conversations, and very often you have unintended consequences of decisions that you make, where you did something and you didn't realize it in the future, but you're actually losing information into the future. There's only one model that will not lose your information, and that's event sourcing. We're going to go through and take a look at that. And I've been using this slide for like 5 years. It's my quintessential example of current state. And this could be an XML document, this could be a document in MongoDB, this could be tables inside a SQL Server or Oracle, but it's representing the current state of an item. It's talking about the shape of the data. And you'll notice here we have a purchase order with n line items and some shipping information associated with it. How many of you have something like this in your system today? Whether it's a document or an XML file, come on, we all have this. At some point, you end up with this. But this isn't the only way of storing information. Another way I can store this same information is I can store it through a series of events. Events are facts that happen inside of the system. So here we can say we have a cart created, 3 items added, and then shipping information added. At any point in time that you want to get back the current state of a cart, I can replay these in memory and I can hand you back this, correct? The thing is, this is transient. I only store these. And that's the core idea behind event sourcing, is that current state is a transient concept. Now, when I say transient, I mean conceptually transient. It may still be persistent. I may put it on a disk someplace. It's not that I always regenerate it in memory, because that'd be stupid in a lot of cases. But all I store is my events. Everything else is a first-level derivative off of my event stream. And I know that's hard for some people when we first start coming through. There's some beautiful things about this. One of them is that there's only one operation. How many have heard the term CRUD before? So this is curb. You can only create and read. We're going to talk more about that, but one of the big benefits of being able to do that is me being able to say, all my data is immutable. Immutability is a wonderful, beautiful thing, and we're going to talk more about that in a little while. But it took me forever and a day to find this particular slide. Why? Because accountants don't work this way. Unless they work for Enron or the Polish government. You don't erase things inside the middle of your journal. You just can't do it. It's illegal. If you've taken an accounting class, you may have learned something along the lines of when you do accounting, you do it in pen. Because once you've written something, you can't go back and undo it. It's there, it will forever be there. Your mistake will forever be enshrined in the journal. You can't get rid of it. But let's say that I were to go through and I were to fat finger and I were to send you 1,000 zloty instead of 100 zloty. Do I just erase a 0 from an accounting perspective? No, I've got 2 options here. as I said, anything you want to know about event sourcing, go and talk to accountants. They already know all this stuff. I'm either going to do what's known as a partial reversal or a full reversal. A partial reversal, I'm going to put a new journal entry. It's going to take 900 zloty back from you and give it to me. Now, okay, that's no big deal, right? You go and look at that log and you're like, well, he put over 1,000, he took back 900, he meant to really send 100. What happens when there's 6 accounts and they're non-exact numbers? And I put through this journal entry afterwards. You end up having to take out a pen and paper to try to figure out what the hell I originally intended to do. So accountants have a tendency of not doing partial reversals. Instead, what an accountant is going to do is what's known as a full reversal. So I gave 1,000 to you. Now I take 1,000 back and said, hey, I screwed up. Then I say I'm going to give you 100. Think about it from an auditor's perspective, coming back through and reading through this. It'd be a lot nicer to read the full reversal than the partial reversal. For this reason, accountants have a tendency of preferring full reversals to partial reversals. It's the same exact thing when we talk about event source systems. We tend to prefer doing a full reversal as opposed to doing a partial reversal. In other words, I prefer to do a full undo operation and then do the operation I intended, as opposed to going through and trying to drop in some finagling event that will bring you to your correct state afterwards, if possible. So what we'll end up with is now we've got a cart created, 3 items added, 1 item removed, and shipping informati unlimited. Doesn't really work that well. Is this the same as cart created, 2 items added, shipping information added?
From the accounting perspective, it's the same.
It depends on my perspective. If I go back and I have this perspective with it, those 2 are identical, correct? Okay, so I have an exercise for you all to try with your own systems. If you can come up with any 2 sets of use cases that leave your data storage at the same place at the end of them, congratulations, you're losing data. How did you determine that data wasn't valuable? We're going to get back to that more, but you've just shown that you do not have a perfect hash. You are losing something along the way, by definition. If I were to look at this and I were to have a different perspective, I might come up with a very different answer. What if I were to have a perspective that counted the number of items that were removed? Would they be the same? No, then I'm going to get 2 very different results from my 2 event strings. One of them is going to say 0, the other one's going to say 1. This not losing data is a huge thing inside an organization. And most people don't have to worry about data storage sizes. How many have heard of Moore's Law? Processors double everything. So there's a related law, I'm forgetting the guy's last name. But it's a corollary to Moore's Law, and it basically shows that storage grows faster than this. Do you know right now they're talking about 10 terabyte hard drives within the next 2 years? Within the next 5, they're talking about 100 terabyte hard drives. That's sick. I can go out today and I can buy a 1 terabyte SSD for less than $400 US. What would that have cost me 5 years ago, a terabyte of SSD? You'd have to have multiple drives. Well, to be fair, that's all they're really doing internally in the SSDs anyways. They're basically making RAIDs inside of them. It's just I'd have to have an external RAID of many SSDs inside of it. When you start thinking about trying to store all your information, don't think about, oh my God, I'm taking this much on per year right now. Think about where you sit next to that exponential curve, because that's what's really important. Is your acquisition above or below that exponential curve going on for storage sizes right now? If you're above it, okay, you need to have a conversation about this. If you're below it, your data storage is just going to get cheaper and cheaper and cheaper the further that you go. I've been joking that I'm actually going to release a new NoSQL database. Its backing store is going to be Gmail. You give me accounts, I store your data inside of Gmail for you. Well, hell, the APIs have feeds. Why not? It wouldn't even be that hard. Hell, I'll even version your data for you. But storing this data over time can be immensely valuable. Let's just try a quick example really quick. So let's go back to this one. And let's imagine that we're some big online retailer types. And what we've got a question coming from our domain expert. And they say, I'm looking for the items that have been removed from carts within the last 5 minutes before they were checked out. Because I think people are more likely to buy those items in the future than they are the random items that we show them as suggestions from our suggestion engine. And that makes sense, right? Why do you remove an item from your cart 5 minutes before you check out? Because you go and look at it and it's like $300 worth of stuff. And you're like, I can get all of these items and my wife will kill me. Or I can order 2 of these items, remove the rest from my cart, and I can order those items later. You're deprioritizing them. It's not that you don't want them. It's that you're deprioritizing them over some other set of items in your cart. And this seems like a reasonable hypothesis, yes? So what they want is a report for us to go back and actually tell them the answer to this hypothesis. Does this sound like something they could get business value out of? Sure. Okay, so let's do it here. We're going to add a new thing off the top. It's going to be called remove line items. And when someone removes a line item from their cart, we put it up off the purchase order for things that were removed in the process of building up this. And then what we do is we write a report. And that report will look at removed line items, and then we'll do a nested subquery to go see if this customer has bought that item in the future. We release it to production. Our domain expert runs the report. What does he see? Nothing. Okay, maybe there's one guy that was really fast. He removed something from his cart, then he immediately turned around and bought it, so you maybe get 1 positive. But that report runs from the time we release to production forward in time. Let's try it in this model. So what we're going to do now is we're going to create a projection. A projection is basically anything that goes over an event stream and it produces a form of state. And there are an infinite number of projections you can have off of any event stream. Okay, to be fair, it's finite because our clocks actually have a certain level of granularity inside of the computer systems. But it's near infinite. And what I'm going to do is I'm going to look for the item removed. When I find the item removed, what I'm going to do is I'm going to take that item removed and I'm going to put it into my state. And I'm going to say I am looking for the ID of the item in the future. I'm going to look for the checkout. Here's the ID, here's the time that it was removed. When I get the checkout, I'm going to go through all the ones that were removed, find any that were within 5 minutes. And then I'm going to say I'm looking for this item to be bought in the future. If I see that item get purchased in the future, I mark found equals true. Otherwise, it defaults to false. Now, what I haven't told you guys about projections is that projections have to start on event 0, the very first event your system put out. And they have to replay all the way through the event stream to get up to right now. So when I release this, it's going to start all the way back at the first event our system ever put out and start playing forward.
The whole system?
The events that you care about. If you look at Event Store, for instance, we'll index away all the events that you don't actually give a crap about. And the way we generally do this is most projections are interested in event type. And because you're specifying the event types that you're looking for, like here we're looking for item removed, shipping information added, and in the future we're looking for that this thing was actually bought. So we've got 3 event types. So I can only look at those 3 event types and skip all the events in the middle. But conceptually, yes, it looks at every event. It's just we may optimize your pattern match. So if you're not going to match it, I just won't bring it over. Now this operation may take a while. What happens if you've got 1 billion events? It may take an entire weekend to replay your 1 billion events to get back your projection. Do we care? This can happen asynchronously, right? You start off on Friday, go off to the pub, have a good weekend. You come in on Monday, and it's actually built, and then you release report will go against the model that it built. Up to, let's say, 1 or 2 billion events. If you've got more than 1 or 2 billion events, you're probably above that curve in Moore's law we were talking about, and we need to talk about this. But for most business systems, this is not a problem. But now, my business user runs this report, and what do they see? They see all the data. Because I didn't lose anything. And not losing data is a huge ility in terms of architecting systems. Not only can my business user go and look at that report as it stands today, they can go look at what that report would have told them at any point in the history of the system. They might, for instance, ask me, what would that report have told me on July 13th, 2003 at 14:41 and 32 seconds in the afternoon? And I can show them, this is what that report would have told you. Now, why are we doing a lot of this kind of stuff in algorithmic trading? The ability to go back and look at situations in a deterministic way is highly valuable. This is a big part of our safety net. What's the point of having a trading system that can do 5,000 trades per second when it finds a good way of losing money? There's a lot of places in the stock market you can lose a penny at a time. And its ability to do things like go back in time and look at certain situations deterministically and make changes to things and send them back through the same period is quite useful. There's another big use. Okay. So I have worked in both. The trading system in question is not HFT. Because HFT, the ability to replay is less important. It's more important for a quant at that point. The stuff we were looking at was more level 2 order book and efficiencies, where being able to go back was actually quite valuable. And we're going to talk about this in a minute. In particular, what was valuable was our ability to backtest passive strategies.
So you are not storing the whole order book,
just the deltas. And at any given point in time, I can roll you back to any given millisecond based on deltas. And we can go look at exactly what happened. And sometimes we won't even care about time. We only care about sequence. Because sequence is oftentimes more important than time. To be fair, if you're getting into HFT, sequence isn't always something that you can do. Because there's the sequence that things happen versus the sequence that you receive things. I may get a slow packet that came across because a router died along the way. And I've got no way of being able to figure out what the actual time is between me and other things. I can only guess based on distance. But this not losing information is massively valuable. How many of you have an update or delete statement inside of your system today? You can admit it. You guys don't all have insert-only systems. So I want you to keep your hand up if you have an update or delete statement. Now, how many of you sat and talked with the CEO about the risk analysis for keeping this data, maybe did an options pricing model? Why not? I mean, otherwise, how are you going to make your decision? So I know that a gigabyte of data will cost me, let's say, 5 cents to store for a year. And in looking at that, we decided there's no possible value we can get from that 1 gigabyte of data to justify 5 cents of cost expenditure. This sounds like a very difficult thing to get into. But how do you even justify possible value? Like, how do you quantify this? How many of you can guess what your company will ask you in a year about today? So then how do you do the value side of options pricing? Do you use your magic 8-ball, shake it up? Will they need this data? Chances are maybe. There's no good way of actually plugging this stuff in. So as a CTO, my only rule was I will not lose any data. Because I have no freaking clue how to value it. I know it's relatively cheap to store, and if my storage prices start getting really high, well, then I'll start thinking about maybe there's some stuff I don't really need. But your default should be to store everything. because you have no idea how to value anything. It's a really, really simple equation to go look at from an options pricing model perspective. Now, we've been talking a lot about the business side of stuff like this. There's also the programmer pornography side of things. So, one cool thing about event sourcing. It goes really, really fast. Naively right now, and in Event Store, for instance, we have made things easy and safe as opposed to fast. That was our whole goal. Everything is like, when we give you your write has completed, it's been F-synced onto a quorum of disks inside of your cluster. The chances of you losing this are minuscule. We don't apply tricks like MongoDB, where it's like, well, I put it in queue. That should be considered written, right? Hey, it's correct 6 nines of the time. But even with the kinds of things that we're doing, which are meant to be safe and easy as opposed to fast, I'll still get you on a single node up over 100,000 events per second. How many of you are looking at needing 100,000 events per second? And I'm not pulling some bullshit like, oh yeah, we're going to do it with 5-byte messages, which is done way too often in a lot of the benchmarks I've been reading lately. Someone recently was doing, I think it was 6 million messages per second, so long as they were 10-byte messages. That's really useful when my average message size is like 400 bytes. But maybe you've gone and got a disk before. What goes faster, random writes or sequential writes when we talk about a spindle? What's the model that we're talking about right now? Everything's sequential. In fact, this is how a lot of databases are built internally when we talk about event sourcing. If you go look at, I don't know, SQLite. SQLite is built this way internally. It's called a log structured merge. Basically, they're writing down to an event log, then they're coming back up that event log into an in-memory data storage, and occasionally they're persisting down and taking a snapshot of the in-memory storage that they have. Well, it's actually an accumulating snapshot, but close enough. One of the questions I get a lot with event sourcing is, but which big companies are using this? Because that's the best way you should make a technology decision. And my favorite answer to it has become, how about Oracle? Because this is exactly how Oracle works internally if you go look at Oracle. SQL Server works the same. Cassandra works the same. This is not new stuff. This is how most people were doing things before SQL became like popular. If you go back and look at most mainframe systems, they were working exactly like this. They had a transaction log and a series of chasers that updated shared memory. And then basically what you did is you exposed a shared memory contract from your little service to everybody else who could then read from your shared memory. God, I'm feeling old now.
So why the neutral state became more popular than
Because people made it easy. And I don't know how many of you are old enough to remember before SQL was like the thing that you always chose for every project. So I actually remember on my team being approached by the SQL salespeople. And what was hilarious is looking back at it now, every single reason they gave us about why we should switch to SQL is now considered an anti-pattern. So they were trying to convince us to put a whole bunch of data, and one of their main things was, you guys won't have to write screens for this data anymore once you put it into SQL, because the administrators can just come in and edit it in the tables. Just using something like Enterprise Manager or Toad, they can just go in, they can edit the data right in the tables. This is exactly what you guys want, right? Your administrator and just randomly changing data on your tables. What could possibly go wrong? Another one they gave us was, once we put all this data into SQL, then we could actually go through and we could have like all 15 of our systems all hitting the same SQL database to get that data out and to manipulate it. And we could use it as our main integration point for our system. This isn't such a good idea. But getting back to your question about why things have gone mutable, for a huge number of systems, data is mutable, and no one gives a crap about the changes. Huge numbers of systems. Think about your typical web system. You don't care about changes that are happening in your data, you only care about what's current. Aside from that, if I go back 20 years, size constraints were a lot more important back then for data. Where storing purely immutable data and only storing your transaction log, as an example, was far more expensive than what people are looking at today. The rate of growth today is so much higher than it was back then. How many of you have seen the poster with the 1 megabyte hard drive? And they're loading it into a Boeing with a forklift. It's really come a long way. Well, there's some other cool things that we can do if we have an immutable model. How many of you have heard of something called a superuser attack? A superuser attack is when you have a rogue developer or system administrator who is presumed to have root access hacking your system. Oddly, these are slightly difficult to mitigate. But in an event source system, you can actually mitigate these risks. And this isn't a primary use case for building out event source systems. This is a secondary use case, and it's something that's good to have in your toolbox if you happen to run into one of these highly secure systems. Years ago in a gambling system, I actually had to deal with a superuser attack. And the whole story, I'm going to go through it in like 3 minutes probably, is actually an HBO special. They've got a 1-hour HBO special about it. It's called Criminal Masterminds. I'm actually interviewed in the show. What I never understood, though, was all of the episodes of Criminal Masterminds ends up with the guy getting caught. If they were masterminds, wouldn't they have gotten away with it? But we were building out a horse gambling system, and this is in America. So it's basically the system that runs the back end of all the betting on horses. And it was in use for about 70% of the world's pari-mutuel market. And there's a pool type that we had. It was called Pick 6. And what you would do is you would bet the winner of 6 races in a row. Needless to say, this is a very difficult bet to win, and you win a lot of money when you win it. It's basically the equivalent of, for football, betting a 6-game parlay. So basically, it's exponential on each one. Of course, they're going back to pools, but it's still very, very big pools when you win. Now, the problem is, when you bet this, you normally bet very small amounts, like let's say 1's lucky. But then you do 200 bets of different combinations of things you actually want to be able to bet. And what was happening was we were still back on CSU, DSUs, and you can imagine shipping all these tickets back to the host track was very expensive. So what we do is we would actually keep all the bets at your local track until the end of the 4th race. We'd then look at which ones were still capable of winning, and then only ship those tickets over to the host track. It killed like over 99% of our network traffic over the CSU, DSUs. This is a huge win in terms of performance for the system. Now, we had a guy, he actually sat right next to me at one point, by the name of Chris Harn. And he was attacking our system. And what he would do is he would go in, and he would make a bet, 1, 2, 3, 4, all. And then he would get on the developer maintenance line at the local track. He would watch the races as they were happening, and right before the scan happened, he would go edit his bet on disk and change 1, 2, 3, 4 to the winners of the first 4 races. 5th and 6th legs, he had all and all, so this ticket might win. He ended up getting caught, not because he was stupid, but because he's unlucky. And that's normally how superuser attacks get caught. It was Breeders' Cup, and this is probably the biggest security breach in horse racing in America in the last 3 decades. Breeders' Cup is probably the 2nd or 3rd biggest race in America. It's right after the Kentucky Derby. It's not part of the Triple Crown, but it should be. And he goes through and does this in the main Pick 6 pot for Breeders' Cup. Goes through, edits his bet, everything's good. And then the 5th and 6th legs, 2 like 99-to-1 horses come in. He's the only winning ticket in the world. It's like a $1.9 million pot. Now, normally what happens is, you get some level of favorites, and you end up getting 20, 30 winners at the end, and each of them gets paid out $60,000. Nobody thinks anything of it. When you're the only winning ticket in the world, and it's a $1.9 million ticket, do you think the mutual manager is going to take a look at this? And when he sees that your bet is the equivalent of winner, 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 all, those alls are combinatorial. No punter would ever make that bet, because you might as well just put one bet in the pick four at that point. That's a fishy, fishy bet. Like, punters don't bet that way. So what ends up happening? Mutual manager gets on the phone with the local track and says, hey, anything interesting going on over there? Oh, there's a developer on the maintenance line. That's interesting. Oh, the asynchronous audit tape is ejected. That's interesting. To be fair, it's not a big deal if an audit tape gets ejected. It happens in operations. I mean, okay, no big deal. It got ejected. Put it back in. Okay, no big deal. But all this stuff happening at the same time, that's interesting. Needless to say, the guy did not come into the office on Monday morning. And I believe he ended up spending something like 5 years in a federal prison after he turned over on all the other people that were involved with it. I believe he now lives in Peru. But this could have been prevented in an event source system. How many of you have heard of something called a worm drive? Write once, read many. Basically, once you write to it, you can never rewrite that block ever again. Now, I'm writing my log to Write Once Media. I derive my current state whenever I need it by reading from my Write Once Media. How do you attack me at this point? You need to put something into my Write Once Media in order to attack me, correct? How do you get rid of it once it's there? Okay, there is a way you can get rid of it. So assuming I'm doing, like, let's say, one transaction every 10 minutes. What you can do is you can make an entire copy of my worm drive with the one change that you want in it, and you can walk over and switch them. But there's ways I can protect against this. To be fair, there's some amount of time that's required in the physical world for you to move a cable. What if I were to write some form of sequence that was based on the last thing that I was writing, and I were to do it every 200 milliseconds to the worm drive? I could prove at that point that the cable was not disconnected and moved to another drive because you wouldn't be able to do it fast enough. Or I could just go get like 20 special forces guys with automatic weapons and say no one gets in the room. But you have to worry you can still bribe those guys. With the other way, I'll know if you actually switched it. But in general, we're good at physical security. And what you would need at that point is you would need physical access in order to attack me as opposed to root access. Root access wouldn't be good enough. There's other cool things we can do. For me, the most important thing about event sourcing is the ability to go back in time. And anytime you come up with a new perspective for today, you can go look at any point in your history with the perspective that you came up with today. And this becomes very useful for a lot of different things. It's my ability to go back and do things deterministically throughout time. How many of you have ever had a bug in your code that a junior put in? And the worst bugs are when you go through and it's like, well, user calls up and says, yeah, the system was broken, but I fixed it. And it's like, well, where do I see your pull request? No, what happened was the system got into some state that it wasn't working properly. And then what they did was they went through and said, well, click, 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 edit, 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 until eventually it was out of that state that was causing problems, and then started working again. And they fixed it. Of course, what was the state that it was in that they fixed it from? And this is one thing you can do in an event source system. I actually have a little app that I like to use. It's the exact same thing that's running in production in forms of a domain model, but It allows me to say, I want to load it up in a specific version in order to process the thing that it's going to do. So I may go look and I log all the messages coming in. I see Joe is having a hard time at this time this morning. This is the error message he's getting. What version was he running against? Oh, version 19. Bring it over. It's currently at version 31, but run it against version 19, and now let's go into the debugger and step through. This also goes a long way to get me my failing unit test, because what do I have? A series of events with a command? This is very, very valuable. Other things that you can do. Just go back and look at any point in time for any new perspective that you come up with, any new perception. A good way of thinking about this in the real world. Imagine if I could take your brain today and I could send you back in time to your first dance when you were 13 years old. And you could re-perceive everything with your brain today. Only one problem, you can't change anything. You can't change the past. And I highly would not recommend doing that. But all of this is coming from a model that we're actually using. Now, there's an associated pattern with this, which is snapshot. Sometimes I may have so many events that I can't go all the way back to 0 and replay every time. Think about Google's order book at 11 o'clock in the morning. It's got a couple million events inside of it, and it's doing a couple thousand transactions per second. That's a really, really bad idea to go all the way back and replay at every single one. What I can do is I can leave a snapshot that basically says this is the state at this version. And then I can only play from that version forward. Also, event sourcing is a functional model. How many have done some form of functional programming? Okay, let's re-explain event sourcing for you. Event sourcing. Current state is a left fold over your previous behaviors. A snapshot is a memoization of the fold. That's the easy way of saying it. But it doesn't help when you have a lot of object-oriented developers. Event sourcing is a good overall model. But it has some problems with it as well. Now, how many of you have heard of one of these before? You know you're not cool if you're not using these. With the exception of one of them. I'll let you figure out which one. But all these databases suck. And Oracle sucks, and Event Store sucks. Every database that has ever been made sucks. And no matter how much you try, you're never going to find a single best database. They all suck. How many of you use SQL today? Just raise your hands if you're using SQL. Now, I want you to keep your hand up if you made a rational, conscious choice to use SQL. The hands always disappear on that one. It's like, no, we use SQL by default because we were building a calculator. I was forced. That's another good one. To be fair, SQL, the engines that are out there, are some of the most mature software you will find. The chance of you finding a bug in SQL, in Oracle, is very, very remote.
But in using it, it's quite common.
And using it is quite common. You put bugs in. But the engine itself. Well, okay, let's go compare that to MongoDB. Because MongoDB is mature in web scale. But every single database on the planet sucks. All of them. And our biggest problem is we build accidental complexity by trying to choose one. How many of you worked on a project where you had like 3 or 4 different databases? Like different types? That's what you should be doing almost all of the time. Let's go back in time a little bit. You guys are on the JVM. How many of you remember those? Object databases. This may be older than some of you. They were going to take over the world. Object databases databases were the shit. They were basically a deformation of a graph database, and that was made specific to objects. And what was so cool about them was when you build your objects, like comparing with Hibernate, so you build like a sprawling Hibernate graph. Now imagine each object was actually stored as an object reference inside of a database. And then you could just walk the links from one object to another. And it didn't have to do like these weird lazy loading queries and things like that. You didn't have to set any of that stuff up. You just said like, okay, for this object, I want you to bring up objects within a depth of 2 when I load it. Wouldn't that be so much easier? What's more is it was faster. A lot faster. About 10 times faster than using Hibernate on top of, let's say, I don't know, Oracle. Because think about what Oracle has to do in order to hydrate out that object. You got a set operation, maybe with some joins, then you have another set operation that needs to come back. Then you need to map that stuff all to your objects. What was this doing? This would just bring it back in serialized form, deserialize it. In order to move from one object to the other, it was walking just a graph index. You're just going from here to here. And I can tell you all the places you can walk from an object just by going and looking at what connections there are to that node in the graph. And they were so much better because they didn't have an impedance mismatch. How many of you have fought with the impedance mismatch before between object land and SQL land? Or let me try this again. How many of you have used Hibernate? Yeah, so that's what you were doing. You were fighting the impedance mismatch. And this caused huge problems, the impedance mismatch. When people got into these, they were like, oh my god, this is sweet. It's kind of like when people find document databases today, and they go, wow, this is so sweet. Of course, how many of you use an object database today? Oh, we actually have one. You get a prize. And there's this huge upsurge in books and in conference talks and object databases were going to take over the world, and then nobody used them. Why? Well, if I go back and I look, everyone would build out their domain models on top of object databases, and it was freaking sweet and fast, and everything was wonderful. They'd be ready to go to production, and this dickhead business guy would come over and be like, hey, I just need a quick report. Can you give me a summation grouped by town of the sales from all of our customers? And they went, holy crap, I need to load like 200,000 objects into memory to do this. And then I have to write my own code to do the traversing over it, and that, oh my god, this is going to be awful. Think about the deserializations that need to occur. So obviously, object databases suck. Why do people stay with so much with SQL? They stay with SQL because SQL sucks the least at everything. It's not great at very many things except for set operations, but when you try to get it to do things it wasn't intended to do, it doesn't suck that awfully at. It's only mildly painful. Imagine, for instance, trying to take, well, some of you guys might have used a document database before. How fun is it to do a group by? Samples. And next thing you know, you're trying to explain MapReduce to your business users. It turns out wonderful. And then they want to hook up Excel to it and do pivots. Hasn't somebody in the JVM world already built like a pivot adapter for Excel that talks back to MongoDB? But every database sucks like this. And what you're going to start finding is that any time we're getting into situations like this, what we're really talking about is accidental complexity. And event sourcing is great for writing data. Event sourcing sucks for reading data. Okay, so I got my event log with 10 million events in it, and you want to issue a query. I'm looking for all customers whose first name starts with the letter G. So I do a fold over all my customers, come back to now, and then do a filter at the end of that. This will be very fast, I'm sure. Which would you prefer? Big O of N over your transaction log, or big O of log n over current state, like for instance a B-tree index. I have a feeling the B-tree index is going to be a little bit faster, because n is also much bigger in the first case. But this accidental complexity comes very often because we choose the wrong models. Wrong models introduce huge amounts of work into our projects, and very often we don't even see it. Maybe you guys have heard of this little startup before. Now, at its core, Twitter is what? A topic-based pub sub. Yes? Sure, it's got a high branching factor, but at its core, it's a topic-based pub sub. So, as an architect for this system, I'm going to pull out my tools, my weapons of choice, and they're going to be MySQL and Ruby on Rails. I'm going to ignore 3 decades of research in finance, and I'm going to go for Ruby on Rails and MySQL. Has anyone read where they ended up with this? With hundreds and hundreds of extra large MySQL high I/O instances, costing them a fortune. And then they came through and said, you know, maybe we should listen to those kinds of things, and they did it in a different way, and it went down to like 10. This is common when we start talking about these kinds of problems. Picking the wrong model can cost you huge amounts of time in your project. I have watched projects go from 1 year with 18 developers to 1 week with 3. This is the level we're talking about. It's not even 2 orders of magnitude that can be lost due to accidental complexity. We're talking many, many orders of magnitude. How many of you have used something like SQL Server full text indexing? Or Postgres JSON querying? Which do you think does a better job at JSON querying? Couchbase or Postgres JSON querying? What do you think does a better job at full text indexing? SQL Server full text indexing or Lucene? Lucene was built exactly for this. I'm going to talk about this a little bit later, but be very careful. I'm not suggesting that you all go out and get 10 new databases and put them into production tomorrow. We'll talk about the other side of this. Let's try another one for accidental complexity. You guys have probably played this game before. So we've got a table. ID, parent ID, and some data, let's say a string. Maybe we're building up, I don't know, a menu bar on the left side of the screen, and you need to get dynamically the entries that should be on the menu bar. And so you do this code and you push it out to production, and then you get the call. This report is taking 9 minutes, and it's not done yet. You say, well, it works on my machine. But what happened? What happened between your machine and production?
You change the style data.
Yes, on your machine you had 30 rows. In production there were 14,000. What you've built here is known as a recursive query. Recursive queries don't work very well in terms of performance because, well, they're recursive. How many of you have run into this before and built something like this? Now, you guys look like you're pretty smart, so I've got a feeling I know what you did. So then you had ID, parent ID 0, parent ID 1, parent ID 2, parent ID n, where n was the maximum depth that you wanted to support. Because now I can do this really cool thing and I can say, select star from table where ID equals or parent ID 0 equals or parent ID 1 equals or parent ID 2 equals. And then I can do my recursion in memory. Because doing it in memory is a hell of a lot faster than going back and forth over to my database every time. Or maybe you write a stored procedure with curses, which should never ever be done. This is a problem of us having picked the wrong model. I actually have a client I was working with in America that had gone through almost this exact same problem. Except they labeled things differently. So what they had was a person table, and don't ask me why there's a person type called company, but there actually was. And for instance, we could have Joe and Tom, who are people. And then there was another table, it was called the relationship table. And what it would do is it would give you 2 person IDs, and then it would give you a relationship type. Now, I put it here as a string, but the relationship type was actually a lookup. And what they wanted to be able to do was they wanted to be able to say, so given our data from Joe to Tom, can you find a relationship using only these 2 relationship types? Is there a path between them? And they were running this on a Microsoft SQL Server instance that cost more than my house. They were running it on a $500,000 database instance. And of course, you need 2 because you wouldn't want a single point of failure. It was one of those big HP dome type things where, you know, you've got, let's get the 128 IA64 processors, a terabyte of memory, Fusion IO boards, because that'll always speed everything up. And queries were still taking 3-5 seconds to come out of this server that, and by the way, does anyone want to guess what the licensing costs were for this thing per year? You know, SQL Server charges you by core. Let's just say it was a lot. And in less than 1 week, we took all of their data and we put it into this thing called a graph database, which was actually built for solving this exact problem. This was Neo4j, because we were able to fit all their data into a single node. If I weren't able to do that, I might start looking at other ones like Titan or some of the new ones that are coming out. There's a couple that are built on Hadoop that are looking interesting, but I haven't played with them yet. If I can get my data reasonably inside of a single node, Neo's the one I've played with the most so far. And it seems reasonable. The one thing that they're missing, as of now, from my perspective, is good pathfinding algorithms. Everything else they do is pretty reasonable. Now, when we run in Neo, these queries were coming back in less than 100 milliseconds on my laptop. I don't know if you saw my laptop. My laptop's not actually that nice. So it's not even like a current model. It's actually like a version last model. It's the ThinkPad X1. So it's actually an Ultrabook. It's not even built for performance. And whatever you do, do not get the current version of the ThinkPad X1. They took all the function keys and made them like assignable icon pictures. Which if you happen to use any form of editor like, I don't know, Sublime or IntelliJ, or it's really, really annoying to click on pictures like it's a McDonald's keyboard. But this problem was solved by moving to the right model in less than a week. And this is quite typical when we start getting into these kinds of problems. What we're seeing here is that accidental complexity is really what's causing all of these problems. All of that stuff they were dealing with is all accidental complexity because they chose the wrong model. And you'll find this in your domain models too. Even for doing something like processing, transactional invariance. If I've got the wrong model, the amount of accidental complexity that comes into it can be huge. It can be orders of magnitude more than doing it in the proper model. How many have taken some pipeline type code and tried moving it from Java to, say, Scala or Clojure? And suddenly your 9,000 lines of code came out to be like 120. It's the same type of thing. There's things that things are good at, and there's things are not good at. And sometimes picking the right thing is the most important part. Best lesson to learn. Learn lots of different models. One model that I find people overlook today, and it's one of my favorite read models to make. What information on this web page changes depending on which user is viewing it? Nothing. I know a beautiful read model. It's called HTML on disk. Slap Nginx over the top of it, call it a day. All your performance problems just went away. This is especially true for PHP sites. It's like, you mean I don't have to make my 119 calls to MySQL? No, because the data doesn't change. Oh. There's also this thing called a caching header you can put on. It'll do basically the same thing, except Nginx will do the work, not you. Now, I've been talking about this stuff for a very, very long time. This is actually the second time I did this talk. Well, the original event sourcing talk. And that was in 2007. The first time I did it was actually 2006. And I didn't know anybody in the community. I hadn't really gone out talking at conferences, anything like that. And what I was talking about was domain-driven design mixed with some of these kinds of functional ideas, mixed with messaging ideas. And I go into my talk, and my front row of my talk was Gregor Hoppe, Martin Fowler, Eric Evans. I was scared shitless. I think I went through my 1-hour talk in something like 18 minutes. And Eric even came to me afterwards and like, that was a bad talk. There's a video of it someplace, and I wanted to get my hands on it. It was just so awful. This is the second time that I did it. And this time it actually went reasonably well. But none of this stuff is new. And in that talk, I actually introduced one way of actually looking at forms of separation. And that's known as CQRS, which is the dumbest pattern ever. All you're doing is saying that my reads and my writes go down a different path. Nothing more. Because I may want to scale independently, for instance, my reads versus my writes. CQRS was mostly a learning pattern. It was never intended to be like this pattern that people went forward with, and it was basically to get people out of the mind who had been doing domain models, that their domain model does everything. If I go look at the typical domain model of 2008, for those that remember it, you'll remember you had your sprawling Hibernate graph, where everything was connected to everything, and you'd serve DTOs off of your domain objects. There was no concept of an aggregate inside of your domain model. In order to get people from there to the concept of event sourcing, you can't do that in one step. There needs to be multiple steps along the way, and CQRS is one of those steps saying, well, why don't we bypass your domain model for your reads? Let's treat reads and writes separately from each other. Because they're different from each other. If I go look at reads, reads are generally what make databases interesting. Writes are freaking boring in databases. Well, most databases. I was actually doing a talk about Event Store quite some time ago. And I was explaining how our transactional engine works internally. And one of the guys comes up and he says, "Ha! Cassandra works that way too. So you must be like Cassandra. You're a Cassandra clone." Okay, well, SQLite works that way too. So obviously Cassandra is a SQLite clone. All the transactional engines were using an academically backed method of storing data. It's called a log structured merge. You write to a log. You follow the log, building up in-memory indexes, and when they get too big for memory, you put them on disk. And you merge while you're putting them on disk. If one of them gets too, if you get too many of them on disk, then you start merging them on disk. Merging 4 indexes into one big index. And each time that you do this, basically you get rid of the data that maybe duplicated, things along those lines, or deleted, as you do the merge process. It's a dead simple way of dealing with things. Writes for databases are really not that interesting. Oracle versus MySQL, they basically write in the same way. The only thing you really need to worry about is whether or not your data actually gets put on the physical disk, and whether or not you can get it back later. So MongoDB fails. Aside from that, you really don't care about the writing side of your database. It's not interesting. You care about the reading side and how you can read from it. Now, if we talk about how you can read, Event Store is very, very different than Cassandra, which is very, very different than SQLite. The stuff that we merge down into and the read operations we give you is what things are interesting inside of a database. How do you do Neo4j writes into their database? Oh yeah, that's a log too. In fact, almost every database writes to a log first, and then it goes out of that log, puts it into some other structure, and then offers you query support off that structure. Writes inside of databases are extraordinarily boring. Reads are where things get interesting. And one of the biggest differences when we start talking about writes versus reads is scalability. Most systems do not need to scale their writes. Most systems need to scale their reads. Think about a blog. I bet I could run a blog on this watch in terms of writes. But reads, you get a lot of reads that come into one of these kinds of systems. Think about the example we were talking about earlier with relationships and people. It was the query load that was the heavy load in the system. Think about in a database today, the load that gets put on from running a report versus the load from doing an insert. Inserts rarely are your bottleneck into a database. It's your joins that are the bottleneck, or in most databases, it's your locking that's the bottleneck. By the way, if you go look at most systems are doing between 1 and 2 orders of magnitude more reads than writes. How many of you measure this? How many reads come in as operations versus how many writes come in as operations? It's a really interesting metric to have for your system. And I find it's normally somewhere between 1 and 2 orders of magnitude. So, for a question for all you guys with SQL databases, how many of you are optimized somewhere just below third normal form? We'll call it pragmatic third normal form. You're third normal except for where it's annoying. And yet you do 2 orders of magnitude more reads than writes. So you optimized for write performance. Third normal form optimizes for write performance, correct? First normal form optimizes for read performance. I've got a system that does 99% reads. I use third normal form and I wonder why I have a scaling problem. Believe it or not, this is how you can be a consultant. Have we considered a first normal form database here? But reads are very, very different than writes. And it took a lot of people time to get over this. When you talk about event sourcing, what you're really doing is saying we're going to write over here, and then we can have as many read models as we want. Well, let's chat about writing for a minute. Now, we mentioned this before, but event sourcing, you essentially at its core have an immutable append-only model. That's the almost exact model that you want inside of any database. That's the exact log we were talking about in terms of a log structured merge. It's the exact log you will find in your transaction file. It's not a new pattern. This has been around for decades. The only thing event sourcing is really saying is that you can have many things listen to your log. It doesn't have to be built into your database. You can have 5 different things that are actually listening to the same log, and they can be going to 5 different models. And this is exactly what we used to do back in the old mainframe days. You'd have one log that people were writing to, you'd have a whole bunch of chasers that were following along and updating shared memory. The queries would go back to the shared memory. It's the same idea. Has anyone here taken a class in operating systems? This was probably covered within the first 3 weeks. This is not new stuff that we're talking about. A journal or a log. That's all we're talking about when we talk about event source systems. And reads and writes are one form of separation when we start talking about wanting to have many, many read models. But there's other kinds of separation as well. Reads and writes are the most common one. Because you look at your problem and you're like, I want to do full text indexing. Maybe I won't do that inside of my event store, and instead I'll do that inside of Lucene, because event store would be really hard to do that with. Maybe I have a group of users that want to be able to pull an OLAP cube and connect to it with Excel and do pivot queries. Cool. Here's out a projection into SQL Server. Hook it up through SharePoint to Excel or whatever the hell you want to do with it. And dear God, don't do it through SharePoint. I actually saw at a conference about a year ago, they had it was a one-day workshop entitled Getting Your Laptop Set Up for SharePoint Development. And nobody saw the fail in this. But this isn't the only form of separation. Another very, very common form of separation is time. Where I may not use the same read models at the same time frames. And this gets confusing for people a lot of the time. Finance is a wonderful example of this. In finance, there's actually business concepts called intraday and interday. And intraday and interday are two completely different things. So you can either have data from today and up until this exact moment in time, or you can have data from any day previous to this morning. And those are your two options. And they have completely different storage mechanisms, they have completely different SLAs. This is also very common, oddly, in accounting. You have current year versus every other year that has ever happened. In fact, very often what big companies will do with their accounting systems is they will use that accounting system up until the end of the year, and then they put it over here. And they take a new copy of the software on a new server, and they put it here to move forward this year again. And they do this every year. So if you want to go back and you want to run a report from 2009, you have to go over to the machine from 2009 to actually run that report. Well, one of the big benefits that this allows them to do is it allows them to switch accounting software every year if they want to. And they don't have to worry about the migration year to year because they just bring over the account balances at that point. This is very common in business. We can start finding that we have different models for different time periods. And yes, it's very obvious with accounting and finance. But there's some other ones that are not so obvious. And I was dealing with a company about a year ago. They had a big multivariate problem. They had a whole bunch of information coming in, and what they needed to do was to solve, I think it was a 9-variable multivariate problem. And what they were doing is they were taking all their data, they were moving it up into Amazon, into a big Hadoop cluster, and then they would run over billions of transactions a MapReduce job to get out the perfect answer to their multivariate problem. Now, this worked really well. The problem was it would cost them like 35 extra large high I/O Amazon nodes for a little bit over a day, once a month to run this report. And those stupid business people kept saying, you know, this is the most important report that we have. Could we maybe run this once per day or once per month? And they started looking at what their Amazon bill may cost. And we started saying, as I came in, why don't you look at this as two problems? Talk to the business side. So, on your incremental one-day report, do you need perfect results? Or do you need results that give you a good idea of what's going on inside the multivariate problem? We need reasonably good results. Fairly accurate within a certain margin. But every month we'll get the totally 100% accurate ones, right? Yeah. It's cool, you'll still get those. And what we do is we broke it apart into two read models. We had one read model, which was a big Hadoop cluster that sat out there. Then there's a second read model. What that second read model did was it just listened to the event stream of what was going on. It had a series of predictions that it was looking at. Let's just imagine they were looking for the top 100 things that they were currently going to be looking at in the multivariate problem. And it would look to see if out of those top 100 things, any of the assumptions that were being made looked to be off. And if it was, instead of recalculating the entire multivariate, it would recalculate that one tiny slice of the multivariate problem. So only do it for this one thing, not the billions, just one. And it was running maybe 1 to 2 seconds behind real time, without needing the cost of keeping all of those nodes up all the time and doing MapReduce jobs. This is a common use. So what we have is we've got one read model there that's giving totally correct information. 100% correct. And we've got another one that's running on top of it. Because to get the correct information is too expensive, we have another read model that's looking for places where the information is likely wrong. Or changed would be the better way of saying it. In other words, what we came up with yesterday isn't holding up right now, so we should probably recalculate that because we're making decisions based on it. It's watching the top 100 things I'm making decisions based on, and looking for places where the current data coming in doesn't match what I have. And saying, let's recalculate that one tiny slice of the big multivariate problem. And instead of talking about having 35 servers, I actually benchmarked this in a VM running on my 2-year-old MacBook Pro, keeping up with the live system without a problem. Why? Because processing messages in memory is really fast. If all I have to do is like add 1 and subtract 1 to a little thing in memory, it's really, really cheap for me to be doing this. But it allowed to go through and figure out and invalidate thin slices of the larger multivariate problem, to not sit there and do full Hadoop queries every single time. And this is a common theme that you're seeing, where we have different read models based on time. Short distances, I do not give you totally correct information. I give you an approximation. And I may be using that approximation to try to gate a bigger, more expensive read model. Other examples of this, very often in event source systems, people start getting lost in eventual consistency. Why not make a read model that's one of them? If you update data right now, that's the one you query. It's got 5 Fusion I/O boards inside of it. That thing's going to update in what, like a couple milliseconds? So by the time you query that thing, because it's come all the way back over to you over a network, by the time you query all the way back, your data's going to be there. But you only store the last 10 minutes worth of data on that. You don't store any data that's older than 10 minutes on it. All the data that's older goes over to the big servers, and that's where you normally query it from. This is, again, a common pattern. You can have different read models at different time frames, and it will actually remove a lot of your accidental complexity that very often comes from SLAs. You don't need all of your data to have the same SLA for querying. We had an example of this. We used to take all of the level 2 data from, well, we'll just use Canada as an example. We had all of the level 2 data from Canada. At the time, I think we were storing about 10 to 20 gigabytes per day. If we had the American data too, if we factored that in, as over 100 gigabytes a day. By the way, did I mention this was in like 2005? Back then, this was a lot of data. Now, not so much. And we stored all of it. But we didn't store all of it that you could access it instantly. Oh, no. If you wanted me to backtest on a day you had never told me before, so I hadn't made it like highly available, yeah, it's going to take a weekend for one day. Why? Because it was stored off on a NAS over in the corner on a 100 megabit network. Think about how long it takes to pull 100 gigabytes over a 100 megabit network. That's just to bring it over before you've even tried replaying through it or anything. But this is a common thing that we do when we store different models at different time frames. We also associate different SLAs with them. And it can go a long way towards removing accidental complexity. Now, when we talk about event source systems, we want to have these different read models. And I find people completely screw up when they try to do it. And this is what they normally come up with when they want to have multiple read models. So we have a client that's talking to a domain model with Hibernate going back to a third normal form database. Now, I know no one does third normal form. We'll call this a pragmatic third normal form. So it's like somewhere between second and third, where third sucks. And then it has an operation called publish. And publish is going to put off into a service bus, because everybody needs a service bus. On the other side of the service bus, we're going to have some subscribers, like OLAP, a graph database, some stream processing. We could have MongoDB on the other side. To be fair, I'd even use MongoDB at that point because I could replay it. But this is a fairly common way I see people trying to reach these having multiple read models for different purposes. And we're talking about accidental complexity. There's a whole slew of subtleties that are hidden inside of this that will cause you to fail. The first one is that publish operation versus the third normal form database. How many have written to a SQL database and published a message before? So what happens? I write to the database with Hibernate. I'm coming back. I'm about to call publish, and someone pulls my power. I know what we need. A distributed transaction coordinator. That's guaranteed to solve all of our problems. And introduce only a few more. But there's other problems that can come up with this. How do you know that what you wrote into your third normal form database, into your book of record, matches the event that you published to the bus? What if it doesn't? What if there's a bug? How would you fix that afterwards? So now, after the fact, these read models over here, because the event was right, they have the right data. But the third normal form database has the wrong data to make the decisions off of. Okay, so let's just imagine that you found this, because normally you're not going to find it. How would you fix this? Link table from the OLAP model back to the third normal form model, distributed transaction, the update. Oh, this will be sweet. And the other way around isn't much easier. But there's some bigger problems that run into this.
Excuse me, how did we run into this situation that we have proper data in the read model and not proper data in the main model?
Because we're publishing an event and we're using Hibernate to write into the SQL server.
Okay, and?
So if I change my domain object and I've got a field on it called state, and I said state equals Florida, will Hibernate pick up Florida and write it into the database? I hope so, it's what it's supposed to do. But then when I build my event, I put a hard-coded Texas. Or vice versa. Anytime that my write through Hibernate does not match the event that I explicitly raise, I'm doing two operations here. And my two operations may or may not be the same. And I've had many, many teams tell me, we're going to fix this problem, we're going to write unit tests. The problem with unit tests is unit tests do not show you a lack of bugs. Because I could have never written a unit test for this particular case. They only show that for the cases I've actually written tests for, my tests pass. And these things will bite you. It's only a matter of time. If I have two systems that are allowed to diverge, they will. And it won't be you guys, I know all of you are good developers, it'll be a junior developer on the team. Even if that junior was you yesterday. But they're going to end up with these things diverging. And once they diverge, you're basically screwed. But there's bigger problems with this. So we've been running this system now for, I don't know, 6 months. Then someone comes in and says, you know what, we really want a Lucene index. So how do we add a new model to this system?
Quickly.
Quickly. I guess maybe we can write a migration script that took us off the third normal form model into Lucene and do a one-off migration script where we remembered the event that we did the migration at. And before we do that, we'll set up the bus to start pushing us messages. Now, once I actually have all that, I'll start burning off my queue until I reach the message that says this is the one that we took the snapshot at, and then go from there forward. Ugh. This sounds like a lot of work. And it sounds like something that's really easy to get wrong. For anyone that's ever done a read model that's fed off of a queue, what happened when you missed some messages? Not that RabbitMQ would ever miss messages, and I've never had this in production. But what happens when you've missed 10 messages? How do I get those messages over now? The problem is I'm basically screwed. The same is true like if I wanted to replay that model as opposed to being a new model. What we start saying is I need some way for that model to talk back to the other side. And this is a big problem that we start running into. In other words, I need a control channel. Let's even forget about having the third normal form model over there. Let's imagine that's actually an event store on the other side, and we put RabbitMQ in between us as a service bus. I'm going to need, from this side, some way to tell the other side, I need you to resend me the messages. I need some way of telling it to put the messages into my queue. Because we're dealing with a server-driven subscription. By the way, while it's replaying all of my old messages and only for me, what should it do with all the new messages that are coming in while it's replaying the old ones? Should it give them to me now? Should it hold on until the end of my replay and then give them to me at the end of my replay? And how do we prevent it from giving me a message twice through this entire process? There's a whole slew of problems that we can run into with this model. And bringing a service bus in between the thing that's storing your events and where you're actually having your read model introduces a huge amount of accidental complexity. And I've watched team after team after team go down this path. And there's two main culprits that they tend to be using, well, three main culprits that they tend to be using. RabbitMQ, Mule ESB, or N service bus. And they have a feeling they need this thing in the middle, because otherwise, how could you move a message from one place to another without a service bus? And they end up in this exact scenario. The problem is, once you've gotten to this scenario, you're basically fucked. Getting out of this scenario is going to take a while, and it's going to be expensive. So, to highlight this, for most people that I'm dealing with that are building event source systems, I give them a rule. And it's just like one of those rules of thumb that the reason I give you the rule, it has no idea of what you think it's for. So I basically tell you that every time you release your software, especially if you're continuously deployed, you need to replay every projection as part of your release. What would happen if you were in this model and you tried to replay every projection as part of every release? And you have to deal with this whole control channel problem. And by the way, you have to deal with the control channel problem without going down. Because if you're doing it on every release, you can't just like take down the system, wait for everything to rebuild up again. So you need to do it while the system's running and handle the switchover at the end. And that's hard. And it basically forces people out of this model by saying they need to replay their projections all the time. I want you to optimize for being able to replay a projection anytime you want. I should be able to walk over to the team room and go, hey, replay that projection right now, it's broken. And that should be no problem. If I'm in this model, that's going to be a huge problem. And the problem all comes back to a really simple concept. And it's that server-driven subscription that causes all of the problems. When I talk to RabbitMQ, who holds the state of my subscription? It's RabbitMQ, it's not me. And that's the entirety of where the problem comes from. If it weren't for that, if I held my state, then all the problems would go away for my projections. Instead, what we tend to do is we tend to have our events there, and we have each of these three talking directly to those events. And each of those three holds its own subscription. It holds its own state. And the way we do this is known as checkpoint and log. When I talk about an event stream, conceptually, we can imagine it as an appending file where everything has a location inside of that file. It's a queue. When will 2 ever change? Never. So instead of something holding my state for me, I'm going to hold my state. I'm going to say, give me the next one event after event I've never received one before. And it will say, here's event 0. I will process event 0, and then I will mark, I have finished processing event 0. Give me the next one event after event 0. Here's event 1. I go and process it, and then I mark, I have now finished event number 1. Could all of you be doing this at the exact same time? Does it matter how many of us there are? The server basically says, I've got these things and I support an operation. Give me the next n after x. And I don't give a crap where you guys are in the log. I just support that query. Now it seems funny, but there's other things in the real world that work this way. How many of you have a blog? Imagine if we set up a RabbitMQ blog. So I'm going to use RabbitMQ with my blogging engine. So if you want to subscribe to my blog, what you do is you come to the control channel, which is email, and you send me an email saying, hey Greg, I'd like to subscribe to your blog. I'd say, here, we've now created you a queue. Here is the URI to your queue inside of RabbitMQ, and blog posts will appear there for you. Some blog posts start coming out, and you say, well crap, I want to read the old ones too. So then you send me another email, remember email is our control channel here, and I say, okay, cool. You want the old ones? Okay, so now take all the old ones and put them into your queue. Now the big question is, while I'm putting those old ones in, what happens if I have a new one come out? This would make a really piss-poor system for a blog engine. Instead, people use things like RSS or Atom. And this is exactly how RSS and Atom work. You maintain the state of your subscription on your machine. You remember the last URI that you actually got something off the feed on. And you come up and you say, next. Well, actually you say previous, which makes a little less sense. You ask for the previous ones. And eventually, your previous link disappears to tell you that there's nothing left. And that means you should revert to a polling mode. And what you're really saying is, you've gotten to number 5, and then I say, I don't have 1 after 5. And then you come back and you go, well, can I get the next 1 after 5? I don't have 1 after 5. But eventually I will. And we can be tricky about this, and I can even put an HTTP header on to say, I don't have the next 1 after 5, but I suggest you try back in about 14 seconds. Of course, you won't be a good HTTP client, so you won't listen to me. And I will tell you again and again, once per second. But what we're talking about here is checkpoint and log. And we can have different clients all pointing at different positions inside of our log. And there's absolutely nothing new here. And this model will also be known as at least once messaging. This works the exact same way from a client perspective that RabbitMQ does, providing you have 1 client on a given subscription. You'll get the same guarantee. How does it become at least once? Well, give me the next one after 4. Here's event number 5. Okay, I'm going to go do my work. Okay, commit my work, and I didn't get a chance to write down that I had completed number 5 yet. So now what happens when I come back up? Say, read my state off the disk. Okay, number 4. Give me the next one after number 4, please. And now I get number 5 again. You can actually get rid of all your at least once messaging problems in this form of system with one very simple little trick. If you can store your checkpoint atomically with the work that you did, you will simulate transactional messaging. And that's a big if. But if you can do that, you will not have to worry about idempotency anywhere inside that read model. If you can't, then everything needs to be idempotent, or you need to be willing to accept failures due to at least once messaging problems, where you get a message multiple times. But this is a very, very simple model. Now, what happens in this model when suddenly we decide we want to replay? You just delete your storage and say, I want to start from I've never seen an event before, correct? I've got no work to do on my side. I don't even know that you're doing a replay, and I don't care. It's up to your side to do this. And it becomes especially true when you start talking about this in larger organizations where we may have 10 or 20 teams interacting with each other. Do you really want to get the email from Team 6 that they need this data replayed again for the 4th time today? Or would you rather have them be able to do this off on their own? The best is when you get the vice presidents in. Now they're talking about an SLA in order to give the other team a replay. But this stuff happens. Other things we can do. I can start saying that we've got 5 of the exact same model. If you're having performance problems with your new OLAP model, make 5 of them. Does anything on the event side care if there's 5 OLAP models? If all your data fits into one server, how do you scale it? You just bring up multiple. Run them side by side, load balance your requests over the top of them. You don't just keep buying bigger and bigger servers, just use multiples of them. It's a relatively simple way of working. And we've gotten rid of all the things like control channels that were inside of our problem before. If you go down the path of trying to put this service bus in the middle, it will cause massive accidental complexity inside an event source system.
I have one question. Because here we are looking that we're starting from scratch. What if you already have a system that has some data and you'd like to introduce event sourcing? So you don't have the messages starting from 0 point.
Yep. Can we talk about that in the questions after?
Sure.
Just because it's not right in line with what we were talking about.
Excuse me, one more question. Because in the previous model, you showed that the domain model was publishing events to a bus.
Yeah.
And how the events appear in the Muley model?
So here the domain model is writing events back to an event store. There is no third normal form database backing it. There is no Hibernate. So when you give me a command, I do some stuff, I write events into the thing that's going to store my events. And that thing that stores my events could even be Oracle. I don't know if people have heard about it. There's actually an open source framework on the JVM called Axon that has built event stores on top of varying data storages. Like there's one on top of Hadoop, there's one on top of Oracle, SQL Server, MySQL, Postgres, MongoDB. There's probably about 30 different implementations they've actually built that all share a singular contract. But all we're doing is we're putting events back into this log, and this log has a form of an API over the top of it that I can issue a query against to get events that are greater than some given position that I've read before. If you get into some of the more advanced stores, you can even go one step further than this, and you can start getting into indexing between multiple streams based on event type, based on all these different kinds of things. Where I may not be interested in all the events as one giant log, I may have millions of little logs that I want to listen to in varying ways. Okay. Now, just to summarize, wrong models cause massive amounts of accidental complexity. And I can't understand why, oh, I know why it's not working now. I loaded it up as a PDF. Why won't my animated GIF work as a PDF? I guess that makes more sense there. But this is actually a Rube Goldberg machine. And this is how I feel when I start working with a lot of these systems, where they basically built this massively complex thing to do relatively simple tasks. And I really feel like the developers did it because like their job wasn't hard enough. And it wasn't quite worthwhile to just solve the business problems. We had to figure out the way that was worthy of our intellect. So when people come back later, they won't think the people were dumb. I mean, look at all the stuff that we used.
That's not only developers, that's companies have.
Now, aside from that in summary, just using something like event sourcing, what you're really building is a queue. It's an appending log. And an appending log with, especially for smaller systems, an infinite history where you assume that you will never delete any data, it's really, really nice to use in terms of writing. It'll give you great performance. And it's really, really easy to synchronize to a lot of different models that way, because you just follow this really basic method. This is really dead simple. And for most business systems, you're not even talking messages per second. You're talking seconds per message. And when you're in these cases, there's absolutely no need to start distributing anything. Linearize your entire system. If you're less than maybe about 1,000 transactions per second, I wouldn't even consider any form of distribution in terms of writing. I would just be linearizing my entire system. And I wouldn't even consider talking about the storage requirements. I wouldn't consider talking about any of this stuff. Probably 98, 99% of systems fit into this category. If you're outside of that, you're actually an interesting system. But for most systems, we can linearize everything. And as I mentioned, this is good for a transactional model. It's append only, you have your history, you can replay, you can all this kind of cool stuff. But it sucks when we talk about doing this as a read model. And to be fair, there are some places where actually just keeping an appending thing of events is actually a really good read model. People always look at me and go, man, what kind of question would I ask a log of events that I couldn't do better in some other model? Not necessarily audit log. I'm looking for people who said the word Starbucks 3 times within 8 minutes of saying, and then somewhere in the word they also said the word happy. Now I could build out a model to query against this, but I'd be building a model per query in the SQL. Actually just folding over the events, I can actually just give you back results really quick. It's going to be a big old event. Temporal correlation queries work very, very well over event streams. One place we've been seeing this a lot is in the medical industry. There's, for instance, the query language inside of event store is actually built for one query. Can you guys imagine building an entire database and a query language to handle one query?
Yes, when you're looking for specific data, chemistry, physics,
Yep.
where you have a concrete model of lot and very, very big set of data.
This is not necessarily big data. It's just a really hard query. I, as a doctor, want to do a clinical trial. I'm looking for people that were diagnosed with this form of pancreatic cancer, with the tumor that looked like this within this margin of error within the last 6 months. They were then given treatment T1. They were given treatment T1 less than 5 times over the course of a 3-week period and never given more of a dosage that left this variance range. They failed the treatment because over those 5 treatments, their white blood cell count moved in this direction for more than this variance. Okay, now all you have to do is write this in SQL. This is the kind of query that actually works really, really well over events. But they're few and far between. But if you have temporal correlation queries, they do actually work really, really well over this particular model. But remember that read reads and writes are one form of separation, and generally your events you want to be on your right side, you don't want them on your read side. Time is another form of separation. And you can start looking at different models based on different time periods. It's a really good place to start trying to think about separating out your problems. And most importantly, remember that there is no best storage. All databases suck in their own unique ways. Now, before everyone goes back and says, Greg told us we need to use 10 databases.
And none of them Mongo.
To be fair, Mongo has done some things very, very well. Using Mongo's developer APIs, they're quite nice actually. A lot of their operations tools are quite nice. Like the overall experience of bringing it in is quite nice. They've done a great job on it. It doesn't take very long of going and looking to find out some of the things they have not done so well. But before we go off, I want to come back to this slide of complexity. When we talk about using specialized read models for your different problems, and yes, most problems probably need more than one, remember there's the other side of this particular problem. And the other side of this is operational complexity. If you go and bring Neo4j into your organization to handle the little graph query that we did for your sidebar on your navigation, somebody's going to need to know how to work with Neo4j. Somebody needs to know how to install it, how to upgrade it. Somebody's going to need to know how to take a backup. Somebody's going to need to know how to deal with it in an operations sense. What are the error messages they should be watching for when they come out? And there is the other side of this, which is operational complexity. Now, if I were to go into an organization, they were telling me, you know what, we did that exact same thing with ID, parent ID, and, well, we considered using a graph database, and given the performance increases we were looking at versus the operational complexity that we were talking about, we decided that, you know, we'll look at it in the future if we need to. That sounds like a rational, conscious decision. If you go walk in and they go, Neo4j, what's that? That's where the problem comes from. If you were to go in and you were to see you're being brought in as a consultant to deal with a SQL performance issue, and you find out that they're using full text querying inside of SQL Server, and that's where their performance issue is, and you say, have you considered trying Lucene? And they go, Lucene? Is that like a girl we can call, or? That's where the problem comes in. I have no problem at all when people tell me that they've decided due to operational complexity that they're not going to use these other models. And given this model really sucks, but it works well enough right now, given the trade-off of the operational complexity of bringing in another model. Don't run off and try to put 7 models into production, because there's going to need to be somebody that actually understands all of them. And there are costs on the other side, on the operational side. Understand that you can do it, but just because you can doesn't mean you should. The best way of dealing with it is normally to delay the decision. If I can get away with something simple and stupid right now, and I can do it at a fixed cost over a long period of time, well, then I'm going to do that every time, as opposed to bringing in something new from the beginning. Just remember that I'm not saying to go off and install 10 databases in production tomorrow. Especially not if you're installing, like, 4 different key value stores, just because they have a slightly different performance characteristic on one query. And with that, questions? Someone there.
Yeah, once again, you have already a system and you have data and you'd like to switch to event source model. So you don't have this 0 message.
You have 2 choices here. And I want to start by saying, when you say system, normally you don't event source a system. You make event source one part of a system, and another part maybe not event source. I hate to use the term microservice. But we can also use the term after. And I may have some afters in my system that are event sourced and some that are not event sourced. I don't need to event source everything inside of the system. And now let's say we make this on a per actor decision. And on this particular actor, it's never been event sourced before. It's currently over in the CRUD database. You're going to have two options, and depending on the problem, you may use one or the other, or you may use both. And I mentioned before, everything you need to know about event sourcing can be found in accounting. So, we are migrating from the old accounting system in, I don't know, Postgres, to Great Plains from Microsoft. Now we're actually going to migrate the accounting system. I've got two choices now, correct? I can either move over the initial balances of all the accounts and start from there, or I can try to reverse engineer the transaction history out of the old system. And you have the exact same choice of event source. So I can either bring over the initial balance of the accounts, food initialized, which brings over the state of what the old system said, and that's my event 0 for that particular actor. Or I can try to reverse engineer my history out of it. Now the problem with the reverse engineering history is it's oftentimes hard or impossible. When you have a system that's losing data, you may not actually be able to reliably reproduce its history anymore. And it's costly in some systems as opposed to just bringing over an initial. That said, it's going to be a per actor decision, and you have to go back and you have to look at what the other system has and how hard it's going to be to try to reverse engineer it. Does that make sense?
Yeah, so from this perspective, taking a snapshot and starting with it.
Not a snapshot. It's an initialization event. So it's an initialized event that contains a snapshot.
Yeah, I mean that this initializing event makes the state as on the snapshot.
Yes, and it works as a snapshot, but it is an event. It's an event that represents that this thing was initialized into the new system. The same way, when I come in, I do not do a credit into the account. I initialize the account. And there's a big difference between what those two things actually mean.
Do you have some reference implementation of this approach?
I did a very simple one called Simple CQRS. It's on my GitHub. If you Google around, there's a whole lot of them. On DD CQRS, there's a page with probably links to about 30 or 40 different small reference apps. Personally, my favorite ones to read are the ones that are in functional languages because the code just disappears. Well, to be fair, how hard is it to generalize a fold in a functional language?
How do you consider it the security of the system? What question you ask yourself to move forward CQRS in some other system, or as you said,
So I never say I'm going to use it for all of the system. I have done that before, but that was in really isolated scenarios. Normally it's more so on a per actor level, or even a per aggregate, or per type, or per context, or per service, depending what boundaries you want to talk about. So I'm normally looking for a couple things. The first one is this core business information, or is it not? If this is something that's in my core business, I almost certainly care about the data there. If this is ancillary data about lookups, yeah, I may not care. Just give me the current state and whatever. There are, however, some technical reasons that you may want to get into an event source system. One of the big ones is synchronization with occasionally connected apps. Another one is audit requirements or security requirements. Another one may be technical, looking at your read models and realizing that having 5 read models here is just going to make your life so much easier. But for me, the big one, just because event sourcing, it requires me to go think about what all the facts in the domain are. I'm looking for places that have reasonable amounts of complexity associated with them. So they're not just the simple transaction script, oh, look, 4 lines of code, I check 2 if statements.
when you start a project and you have some kind of know what kind of complexity it is, but you're not able to predict the future.
You can never predict the future as to where things will go.
So it became more complicated. So you
It can actually help with that, but I wouldn't do that. I would call Yagni on that. I would normally prefer to start off doing the simplest possible thing that we can. And if the simplest possible thing we look at, it's all just basic CRUD, then I would do that and do it really fast and let everybody know that we're doing it really fast and hopefully build up some trust so later when they dump a whole lot more, I can go, you know what, it's not fitting well in our model anymore. And they will trust me enough that I will actually be able to get it done.
And what about concurrency? Because all this event log is quite sequential. In reality, in a bigger system, things can happen concurrently. So for instance, 1 and 2 can be at the same point of time. And we have to put them sequentially. One was before and one was after, but it may change the state of the system. For instance, if 3.
So let's start simply. If you have less than tens of thousands of events per second, then I'm not worried about it. Because I can linearize you at this point, and it's no problem. And when I linearize you, then no, you don't have things happening over here, over here, and over here, because I'm linearizing them all on one thread at some point. Internally, I will linearize them onto a single thread, up to tens of thousands. Beyond that, remember that you can have a stream per actor if you want. And what people do here is they use optimistic concurrency. So let's imagine every bank account in the system has its own stream. Now I'm ready to account for, and you're ready to account for. You load it up off of event 107, I load it up off of event 107. When I go to write, I say expected version 107. Okay, my write works, because it's still at 107 right now. You go to write, and you say, I expect it to be at version 107. Except it's at 108 now, it's an accepted my write, so you get back an optimistic concurrency exception. This is one way of handling it if I actually want pure consistency. If I don't care about pure consistency, then what we can do is we can both just say expected version any. I don't give a shit. Just put it at the end of the log. And it's still going to end up being linearized at some point in the system. Now we can talk about whether it's linearization per key or whether it's global linearization. For small systems up to say 10,000 transactions per second, global linearization is no problem whatsoever. As we get bigger, you start saying, well, we want to do 2 million events per second. Yes, global linearization is probably not going to work at this point. And we have to start building out a whole lot of other things on top of it. We can't necessarily, if we want to do global things, we can't assume anymore. If I'm doing a follower of a single log, so a single bank account can do still 10,000 per second, and we get 1,000 bank accounts each doing 10,000 per second. Listening to any one of them, you'd still have linearization, but listening to 3 of them, you don't necessarily have ordering between the 3. Does that make sense? So if I want to start spreading out over many servers, and we don't have a global log, a single log globally anymore, within a given key, I will still guarantee you linearization. Between keys, I will not guarantee you linearization anymore. At that point, you need to have something on your own that's basically that's merging the streams together. And there's lots of different ways of merging streams together, and we can get into different consistency models. Causal consistency is a good one to talk about. Another good one is, and this is what Google does a lot of, atomic clocks. They're quite useful. If I actually put an atomic clock into every single machine, well, then we've got a really close idea as to how close these things actually were, and we can order based on that. What you're actually getting back into is a wonderful research paper if you want to go spend some time on it. Leslie Lampert, 1978, Ordering of Events in a Distributed System. But in general, if I can bring them down to a single, like within a given key, I can give you pure linearization. It's only when we talk between multiple keys that I may or may not be able to give you a linearization. And there's been lots of things that are built up off of this.
There are so many systems. You process so many transactions.
Yeah. To be fair, if you're in the bottom 98, 99% of systems, you shouldn't care.
Yeah.
Just globally linearized, call it a day. Again, how many people here are doing 1,000 transactions per second? Yeah. So pretty much everybody else, like, don't worry about that question. It's really not that much of a concern.
I have a question about read consistency.
Yeah.
Because if you are writing to this load,
yeah,
and then the read is out of your projection, and the projection is doing a pull on your event log, and then you will always, let's say, have some kind of eventual consistency between what you write into the event log and what the user sees out of your projection.
Correct.
And if you have this requirement that if user, for example, on one screen he issued an invoice and goes to the second screen, he needs to see the invoice that he just issued. How do you deal with this kind of requirement?
Sure, no problem. So, first of all, it's a form of eventual consistency. It's actually a stronger guarantee than eventual consistency. It's known as linear consistency. The projection, it may be behind, but it will never be missing something that's behind where it is, correct? So if it's at event number 3, it's never going to be that event 2A suddenly shows up behind event number 3.
Yeah.
When we talk about eventual consistency, things like, I don't know, how about REOC? In REOC, things can appear 3 days later and I've been making decisions off of them. But I just never knew because it was in a minority partition and it just showed up. And this is a bit different in that between eventual versus linear consistency. With linear consistency, I've got a trick I can do.
Okay.
So you asked me to do a write, okay? Now let me get my chalk. Of course, there's not more than one color. That'd be way too easy. So I do your write at 6, right? So now I return you acknowledgement, 6. Now your projection is over here. And it's writing to a database, right? And in this database, he keeps a thing called POS. It's that same checkpoint we were talking about. So now, he's coming up, he's on number 4. He finishes number 4, so he updates number 4 down here. Now when you do your query, you join that position into the query that you want to do, and you say, where is greater than or equal to 6? It'll return you no rows. That means it's not ready yet. It goes to 5, it updates to 5. You join in that little ID and you say, where is greater than or equal to 6? You get no data back. It's not 6 yet. It comes up to 6. This gets updated to 6. You do your query and all of a sudden you get your data back and get notified that it's actually ready. This is exactly how your database works internally. This is exactly how you do consistent queries inside of a database with a log.
But I have to implement all that in my program, right?
If you want to grab full consistency, this is one way of doing it. You can do this in a generic way. It's not hard to implement. I would actually just do this inside of my thing that sat on top of the read model for consistent queries. You give me a version that you want, and I look down and I go, oh, it's not ready. Okay, let's wait a second. Oh, it's not ready. Okay, let's wait a second. Oh, we're there now. Okay, let's let your query go. We're talking about maybe 15 lines of code, even in Java. But this is exactly how databases are working internally in order to give back consistent results. What they're doing is they're marking a position in a log, and then they're updating off on the side, and they're not going to tell you if this stuff's actually happened until that stuff's actually been brought in over here. You could do it the other way as well, and I can make sure that I don't acknowledge you until this thing has actually been updated with that. There's many ways of skinning this cat, and it's not that hard. The problem with this is what you do when... So I give you back number 6, you're supposed to show an invoice on the screen, right? Okay, so you asked me for the data, I'm on 3. So you asked me for the data, nope, I'm on 3. So you asked me for the data, no, I'm on 3. No, I'm on 3. At what point do you, like, give up or something? I mean, are we going to sit here doing this all day? At the end of the day, most business systems we deal with are already eventually consistent. And the trick is understanding the eventual consistency and learning how to deal with it. from a business perspective, not from a technical perspective. There are a huge number of things that I can do to turn and make it so people don't see eventual consistency. There's a lot of UI tricks I can play, things along these lines that I can do. I won't go into it now, it's like an hour and a half long discussion. I can actually do an entire talk on that.
Two.
But there's a huge number of tricks that we can start playing to get around eventual consistency problems, or at least minimize the issues that come up from it. But this trick will give you 100% consistency. The only problem is, as with anything else, what happens if this stops incrementing? Eventually, at some point, you're going to have to tell your user that this was eventually consistent and piss off. Because I don't have your result yet. I mean, you go to Priceline.com and you say search, and William Shatner comes up and he says, I'm looking for good prices for you. I'm negotiating. How long are you willing to look at William Shatner before you Control W? And it's something that we have to take into consideration. There's lots of examples out there if you want to learn how to do eventual consistency well. Amazon's a good one. Like looking how Amazon actually works, because nothing they do is actually consistent. Have you ever noticed when you go in like, the Kindle store and you say buy book, that thing happens in like 100 milliseconds. Those Amazon engineers must be wonderful, because everyone else in the world takes a few seconds to run a credit card. Maybe they built their own fiber backbone to all of the banks. No, the things don't actually charge your credit card. They just go, yep, cool. Your order is ready for download. And there's ways of working around this, and you have to start thinking about how you want to have problems. Like, in the case we are looking at here, yes, we'd be fully consistent, but we would be running a risk of a big problem. What would happen if the back-end projection went down? Well, then no one would get their data. When people talk about a nines of availability, my big question is always, what's the grouping of them? Is it you have no downtime, no downtime, no downtime, and when we say downtime, I mean a use case actually being answered properly. So you have no failures, no failures, no failures for a year and a half, and then you have 4 hours of every user getting a failure. Or is it every once in a while, you get a failure here, and then the next day there's 3 failures, and the next day there's 2 failures. If I go with this model, I run the risk of a widespread outage. That thing stops working, everybody's done. Everybody's screwed at this point. Whereas with an eventually consistent way of handling this, I might have small isolated failures that are happening over time, but I've removed my risk of a widespread outage.
The thing you are talking about, for example, happens while booking plane tickets. For some companies, when you are booking the place, it can happen that, let's say, 1 day after or half an hour after you receive an email, oh sorry, there's no place for you.
Yeah, and it will happen.
Yeah, of course, but there are a lot of cases when user actually doesn't expect eventual consistency, and user doesn't, and all the tricks that we can do with the user interface, they are not applicable. And the question is, should we then consider...
I find them very few and far between. You're saying there's lots and lots of them.
I'm just, for example, data entry applications. Yeah? And the question is, should we use CQRS architecture for just plain data entry when somebody enters the data and just wants to see the result that the data was entered? And there is
so data entry is a horrible example of where you want consistency. And you'll see this in a lot of the old CRUD data entry screens. And it's one of the most horrific user experiences that you'll ever find in terms of a pattern. So I say I want to have a new customer. And I put in all my customer data,